Welcome to this video which is covering coordinate geometry of the line, so specifically for Leaving Cert higher level. So we're going to look at the new formula which we are going to need as we move into the Leaving Cert higher level course. And before you look at this video, I would advise, if you haven't already done so, to revise the key elements of the Junior Cert higher level course, and to help I have linked the revision video in the description below. So in this video, we're going to cover examples of how to use the area of the triangle formula. We're going to look at the internal division of the line formula, perpendicular distance formula, and angle between two lines formula. We're then going to look at some specific exam questions for the line. And I've taken some more difficult questions from kind of the sample papers given to us by the SEC at the very start, and some of the older questions that are a little bit more difficult. So we're going to look at 2013 paper 2 question 3, 2015 paper 2 question 5, 2014 paper 2 question 5, and the 2014 sample paper 2 question 3. So all 25 markers, all section A questions, but will give us some good opportunities to use our formula that we'll have worked through at the start of the video. Just to be aware that most of the line formulas that we're going to encounter here will also be very, very useful as you work with the circle. So oftentimes, and we're seeing it more and more, that the questions are more of a mix between the line and the circle, and especially the circle questions incorporate a lot more of the line in them. So we're going to be working with our formula and tables book, page 18. So at Junior Cert, we would have worked down to the equation of PQ. We now have two more formula on this page, the area of the triangle and the point dividing PQ in the ratio A is to B. We're also going to work on page 19, and there's two more formula here at the top. So the distance from a point to a line, that's the perpendicular distance formula, and the angle between two lines. The rest of page 19 is all got to do with the circle. But like I said, a lot of our formula that we're going to see now will be utilized quite a bit in the circle. So let's jump straight into an example. So find the area of the triangle ABC given A is 2, 3, B is -5, 1, and C is 3, 1. So we have the area of a triangle formula, and it's given to us here. It is the area of triangle OPQ, and really bear in mind that that one letter is O. That O stands for origin, which means 0, 0. If you look at the formula only takes 2 points, but we have 3. It's not a case where we go and say, well, look, I'm going to take sum two of these three points, because then everyone will get different answers. So what we're going to do, we're going to do a translation. So a translation is a movement of a point. So I like to work down my page when I'm doing translations, and you pick one of your points that you're going to move to 0, 0. It doesn't matter which one, so even if your translations are different, you should still get the same answer. For ease, I'm going to move A to 0, 0. So I need to figure out, well, how did I do that? So the X value I took away 2, the Y value I took away 3. So I'm going to do exactly the same thing for my 2 points here. I'm going to follow the exact same logic, and I'm going to work out B dash, and that is going to be -7, 1 minus 3 minus 2, and C dash is going to be 1 minus 2. So there are my 3 points, and we're going to label. We ignore 0, 0 because that's the point that doesn't go into our formula. We get x1, y1, x2, y2. If you accidentally try to put 0, 0 in your formula, you're going to get an area of 0. So my actual formula is a half. Absolute value signs or modulus signs, that means whatever is in them must be positive. We get -7 by -2, -1 by -2. So that's a half. 14 plus 2. So that is a half of the absolute value of 16. Now, absolute value, like I said, means it has to be positive. This is okay. 16 is positive, so it's a half of 16, and that gives us 8. They didn't tell us what we have, so we talk about these as square units. So example 2, this is again using the area of the triangle formula but in a different way. So it says given the area of the triangle ABC is 12 square units and the points are A, B and C, find two possible values for K. So some things when you're reading a question to know where it says two possible values of K. So we should end up with 2. Don't worry too much for the moment as to where they came from, but we do have our formula here, and just like before, we need to set this up so that one of these points is 0, 0. Now, for ease, when we don't know one of our coordinates, like C, avoid using C. I'm going to use A again to go to 0, 0. And I'm going to take away 4, take away 1. So take away 4, take away 1. And for C, take away 4, take away 1. So I get minus 5, minus 4. And C, so that's B dash, the image of B under a translation. This is C dash, so I get minus 1. Now this one's a bit more, well, not complicated, but it just is not going to be as nice looking. So my coordinate for C dash, so the image of C under the translation, is K minus 1. So I label my points x1, y1. Remember, I don't use 0, 0. x2, y2, and I go to my formula. I have a half of x1 times y2, k minus 1, minus x2 times y1. And that should equal 12. So first thing I'm going to do is I'm going to multiply both sides by 2 to get rid of my half. And I get minus 5k plus 5. Minus 1 by minus 4 is plus 4 minus 4. And this equals 24. Cleaning this up, I get minus 5k and I get plus 1 equals 24. Now, my absolute value signs mean that what's in there must be positive. The problem at the moment is I don't know what k is. K might be positive, k might be negative, and depending on the value of k, what's in the bracket might be positive or it might be negative. So there's two ways to deal with this. So the first method, and the one I would generally suggest that students do because it'll work in all cases, and it's one that we would have seen when you're working with absolute values and inequalities. So that method is to square both sides, because if I don't know this minus 5k plus 1, if I don't know if that's positive or negative, by squaring it, I now know for sure that it's positive. So I end up with minus 5k plus 1. It's still squared, but I drop the absolute value signs, and we've 24 squared. So that's 24 squared, 576. Squaring this, I get 25k squared minus 10k plus 1 equals 576. Tidying up this quadratic, k squared minus 10k minus 575 equals 0. So everything is divisible by 5. 5k squared minus 2k. 575 divided by 5 is minus 115 equals 0. You can factorize this, or you can use minus b if you think the numbers are too big for you to work with. I'm going to work with guide number here. So guide number gives me a minus 575. I want to get to minus 2. So actually I have minus 25 and plus 23. One little trick is if you have a number that's quite close together, you want the factors to be quite close together. So this is a 2, so they will be. If you do square root, now you won't get an exact answer for the square root of 575, but it will give you kind of what number multiplied by itself, so where there's no difference. And you can kind of work up 1 or 2 above or below, and you'll get your answer very, very quickly. So 5k squared minus 25k plus 23k minus 115 equals 0. So 5k, we get k minus 5, and 115. it is divisible by 23, so plus 23, k minus 5. If you hate working with this, you can go straight to minus b, no problem at all. Plus 23, k minus 5 equals 0, so k equals 23 over 5, so minus 23 over 5, and k equals 5. So there are two values for k. So a second method that you could work with from this point, so the start it's exactly the same, but it's just dealing with that absolute value sign. So method 2 is this idea, well, it could be positive, it could be negative, but we're definitely taking it as positive. So therefore, one option is minus 5k plus 1 is equal to 24. So we didn't have to change the sign. And option 2 was minus 5k plus 1 actually was a minus 24, and we did change the signs. So here we have minus 5k equals 23. So k is equal to 23 over minus 5. Here we get minus 5k is equal to minus 25. So k is equal to 5. And we get two answers, and we get them a lot quicker. So this is a nice, quicker little method. Just make sure that you fully understand it if you're going to use it. For some of our questions, our exam questions, this method is a lot easier than squaring. I suppose squaring, you're always going to be able to square. In this case, I would advise students against using method 2 when we've inequality signs, but it definitely is a nicer way to finish this particular question. So example 3, using the area of the triangle formula. So again, we're going to use this, but for a different reason. So find the area of the triangle ABC, given A is 0, 0, B is 1, 3, and C is 2, 6. Now, nice that they've given us this 0, 0 point, so I don't have to do a translation. So I'm going to work with just my B is 1, 3, and my C is 2, 6. I get x1, y1, x2, y2. And our formula is half of x1 times y2 minus x2 times y1. And that's a half of 6 minus 6. And it's a half of 0, which is 0. So the area of the triangle is 0. Is 0. So what can we conclude about that? Well, if there's 3 points and they don't make a triangle, so let's draw 3. So 1, 2, 3, they make a triangle, they have area. So the only way we could draw 3 points and they don't make a triangle is if they lie on the same line. So these 3 points must lie on the same line. So these 3 points are said to be collinear. So 3 or more points are said to be collinear if they lie on the same line. And to add to that, the area, get rid of this, sorry, now this is very messy, try again. So the area of the triangle will equal 0. And that's our quick way to see if 3 points are collinear. We're going to see a few different ways where we can work with this idea of collinear on the same line, and this idea of triangle area equals 0 is one way we can work with it. So example 4, we're going to move into the division of a line formula. Now some of the books have an internal and an external division. Internal division is all that is required, so if the book's a little bit older, bear that in mind. We're only dealing with the formula as per the log tables. Some of the books label it slightly differently. My suggestion or my advice would be that you work with what you have in your exam. Like, why learn off a formula that's different if you're not going to have that formula in the exam and you have to remember it? Anything you have to remember, there's a chance you're going to get it wrong. So only learn off what you need to learn off. There's no point learning off formula that are in the or in your log tables and that you get in your exam. So we're talking about dividing a line in a given ratio. Don't get put off by the word ratio. Sometimes students find that a little bit overwhelming. With this formula, the important thing to remember is when you're given the line PQ, we're going to find a point which divides PQ in the ratio A is to B. So it is important the order that we do this. This is probably one of the few formulas where order is important. So here we have the point minus 5, 8, and we have the point 3, minus 8. If that is AB, it ends, they're each end of a line segment AB. So the ratio A is to B must be given as 3 is to 1. So it's really important that A comes first. So try again. X1, Y1. This is X2, Y2, and then our ratio is A is to B, so we can fill into our formula. So our formula is B times X1 plus A times X2 all over B plus A. That gives us our X coordinate. And then B times Y1 plus A times Y2 all over B plus A. Tidying that up, we get 4 over 4. Here we get minus 16 over 4. And we get 1 minus 4 as that particular point. So it's not a very difficult formula to use once you get to grips with the idea of what we mean by ratio and how it is divided. It's one that students tend to want to avoid, but what I would say is it can make so many questions, especially in the circle section, so much easier to use this division formula, so don't shy away from it. So we're going to use this formula again, and this time what they've done is they've given us our ratio, they've given us our 2 points, but we're missing our X coordinate of the first point and our Y coordinate of the second point. So let's set this up as we have before. So we have X 0, B is 0, Y, and our ratio is 4 is to 3. So we have X1, Y1, X2, Y2. We have some zeros, which is lovely because that will make our lives a little bit easier. We sub into our formula, we get B times X1 plus A times X2, and we get 3 plus 4. We then have B times Y1 plus A times Y2, 3 plus 4. And we end up with 3x over 7, and here we get 4y over 7. Now, we actually know that that should give us the point C, 9 minus 8. So we can create two little equations. The first is, well, 3x over 7 should give me 9. So what we get is 3x is equal to 9 times 7, so that's 63. So x is equal to 21. Our second part that we want to look at is the y coordinate. So 4y over 7 equals negative 8. So 4y equals minus 8 by 7. So that's minus 56. And dividing that, we get minus 14. So our points are A is 21, 0. And B was 0 minus 14. So we can work backwards, and that again is another nice way to use this formula when we don't know one of the points, or even if it's just one coordinate from each point we don't know, and we can work with knowing the answer, knowing the coordinates in terms of unknowns, and working backwards. So our last example using the division of a line formula is going to be finding the actual ratio. So this time they tell us that A and B are endpoints on a line segment. The point P, which is 2 minus 2, divides it in the ratio H is to K. Find that particular ratio. So we're going to work with this exactly like we've been working so far. We take our two endpoints of the line segment, which in this case is A and B, and we have HK, which is going to be our AB. So our ratio A is to B. This is x1, y1, this is x2, y2. We sub into our formula. So our formula is B, which is k times x1, which is 4, plus A, which is h, times x2, which is minus 2, and that's all over k plus h. Our second coordinate then is B, which is k times y1, which is minus 3, plus a times y2, which is 0. Nice to see a 0 in there. That makes our lives a little bit easier. K plus h. Let's clean that up a little bit. So we get 4k minus 2h all over k plus h. That's our first coordinate. And then we get minus 3k all over k plus h. And that should actually give us the point P, which is 2 minus 2. So we can create two little equations from this. So working with the x coordinate, we have 4k minus 2h all over k plus h, and that should equal 2. So we get 4k minus 2h is equal to 2k plus 2h. Bringing this across, we get 2k equals 4h, and I'm going to call that equation 1. You can simplify that again, but let's just leave it here for the moment and see what else we're going to need. So working with our y coordinate, we get minus 3k all over k plus h is equal to minus 2. Minus 3k is equal to minus 2k minus 2h. When I clean that up, bring that across, so minus 3k plus 2k minus k is equal to minus 2h. So k is equal to 2h. So what we can say now, we've actually just got the exact same thing. If we look at it, so we've got the exact same thing for both equation 1 and equation 2. Equation 1 could be divided across by 2. So what I'm going to do now is to put my ratio, instead of saying h is to k, I can say, well, h is to, instead of k, I can write 2h. So that's in the ratio 1 is to 2 when I cancel out those h's. So I can write 1 in terms of the other. So I didn't need to work through with that y coordinate, but it is a good idea just to make sure. You might get an easier answer on one, it might work out better. If something has gone wrong, you'll pick it up if these two don't give you the same answer. So our ratio h is to k is 1 is to 2. So now let's talk about the perpendicular distance formula. Often when we're talking about the perpendicular distance, we can think of it as our shortest distance. There is an infinite number of distances between a point and a line, but if we want the perpendicular distance, that is the shortest distance. If they just ask you in a question for the distance between a point and the line, then chances are they're asking for the perpendicular distance. In an exam question, it will be very, very clear. The books tend to be a little bit more ambiguous. So sometimes students say, but how would I know that that is the perpendicular distance? And I suppose, like, my answer is, there is an infinite number of distances. They obviously want one specific distance, and that specific distance that they will be looking for is that perpendicular or shortest distance. So we're just going to use this formula very basically at the moment. We're going to say our point is 1 minus 4, and our line is 3x minus y minus 2 equals 0. I'm going to label that so I get my point is x1, y1. This is in the form, my line is in the form ax plus by plus c equals 0. So for me, that gives me a equals, b equals, and c equals. I would advise you to do this out, just so it's really clear, because you can really easily drop a sign. You can really easily forget to pull out the minus or take the wrong number. So it's very clear here what my a, b, and c is. So my formula is a times x1 plus b times y1 plus c in absolute value or modulus signs, square root of 3 squared plus minus 1 squared. And we're going to work this through. So we get the absolute value of 3 plus 4 minus 2 all over the square root of 9 plus 1. That's going to give us 3 and 4 is 7 minus 2. So the absolute value of 5 over square root of 10. absolute value of 5 is 5 over the square root of 10. If you put that into your calculator, it's going to rationalize the denominator. So what that means is it multiplies top and the bottom by the denominator just to make it a rational number to get rid of that square root. So we get 5 root 10 over 10, and that cancels to root 10 over 2. So we can leave our answer as root 10 over 2, and your calculator will do that simplifying for you anyway. But there's our final answer. If they don't say to put it in decimal, I would say leave it in third because it's more accurate. So we're going to work with the perpendicular distance formula again, and this time it's asking us to find the distance between two parallel lines. Now our formula works for a point in a line. So if I have two parallel lines, one thing that often I see students do, and just to be careful, is they actually work through, and it's quite clever, but just be careful. I have two parallel lines here, and they say the distance between it is this vertical distance between where it cuts the y-axis. Now, it wasn't clear in this question, but when they want the distance, what they're looking for, unless they tell you otherwise, is going to be the perpendicular or shortest distance. So that line here that I've drawn between them, that red line between the two y-intercepts, that's definitely not the shortest distance. The shortest distance will be this here, so that goes at it at a right angle, so that perpendicular distance. So what we're going to do is we're going to find a point on the line. It doesn't matter which line I take. I'm going to just label it for myself 1 and 2. I'm going to put a big cross through this. That's definitely not the way to approach it. I'm just showing some of the things that can go wrong. I'm going to take equation 1 and I'm going to find a point on it. And I'm going to let x equal 0. It doesn't matter what point you take. I would say let x equal 0 or let y equal 0. 3 times 0 minus 4y plus 12 equals 0, so y actually equals 3. So my point is 0, 3. So now what I'm going to do is I'm going to find the distance between 0, 3 and this line. I can use any point at all as long as it's on the line. So here I have x1, y1, ax plus by plus c equals 0. I have, in this case, a equals here, b equals here, c equals, that's 3, nope, change my colors, that's 3 minus 4 minus 1. So my formula is, I'll work over here, a, which is 3 times x1, which is 0, plus b, which is minus 4 times y1 is 3, plus c, which is minus 1, all over the square root of 3 squared plus minus 4 squared. Working that through, I get minus 13 here, all over 5, so 9 is 16, and so that's minus 12 minus 13, and then that becomes 13 over 5, or if you would prefer to write it in decimal, we get 2.6 units. So we're now going to start into some probably harder examples of using the perpendicular distance formula. So find the equations of the lines which are parallel to the line 3x minus 4y minus 1. Now you can work this through, but if you can remember, it'll make your life much easier. But the x and y coefficients won't change for parallel lines. So this is the general equation of all lines that are parallel to the line that we were given, this 3x minus 4y minus 1. So all that changes is that constant, that plus c. So we're working with that as our line. So that is our ax plus by plus c. So a equals, b equals, and c equals. The reason we're taking that as our line is because we'll never be able to figure out a point on it because we don't know exactly what that line is. So instead what we do is we look for a point that is on the line 3x minus 4y minus 1 equals 0. So you can sub in a 0. Now if we sub in a 0, it's not going to work out very nicely. You'll have fractions. Now there's no problem with working with fractions, but let's see if we can get one that isn't a fraction. So I'm going to try x equals minus 1. So that gives us 3 times minus 1 minus 4y minus 1 equals 0. That gives me minus 4y minus 3 minus 1 minus 4 equals 0. So that gives me y equals minus 1. So my point is minus 1, 1. No, minus 1, minus 1. Apologies. So that becomes my x1, y1, and I sub into the formula. And when I sub into my formula, we get a x1 plus b y1 plus c all over square root of 3 squared plus minus 4 squared. We know that that should give us 3 units. So my denominator here gives me 5, so I'm going to clean up what I can. So I get minus 3 plus 4 plus c all over 5, and that should give me 3. Tidying it up again, we get 1 plus c equals 15. Now, two ways where you can how you can finish this off. We can use our squaring, but I'm going to use the second method that I showed you before that's a little bit easier. So we could say 1 plus c was 15, or 1 plus c was actually negative 15, and we change the sign. So remember that absolute value signs, those modulus signs, they mean that whatever is in there needs to be positive. So if it was negative, we change the sign. So I get c equals 14 and c equals minus 16. So find the equation. So equation 1 is going back to what we had up the top. So 3x minus 4y, we have plus 14 equals 0. Here for the second equation, we get 3x minus 4y minus 16 equals 0. So you can square that out, square it, you'll get a quadratic with big numbers. You probably use minus b, and you should still get c equals 14 and c equals minus 16. So let's look at our last example for the perpendicular distance formula. So this is one that's not maybe obvious about perpendicular distance, and it's not really talking about distance at all, but it's talking about where points lie in relation to a line. So if I have a line here, and this is 5x minus 4y minus 30 equals 0, I want to figure out, do these points lie on the same side or different sides? Now, sometimes students prefer to do this in a more practical way and actually sketch out that, well, I say sketch, actually accurately drive that line, accurately plot the points and be able to figure it out that way. That's absolutely perfect. We're going to use the perpendicular distance formula to help us. So we're going to take ax plus by plus c as our line. That gives us a equals 5, b equals minus 4, and c equals minus 30. So 5 minus 4 minus 30. We're going to take each of our points. So 5 minus 2 as our first point. So that's x1, y1. And we're going to work this through. So we get 5 times x1 minus 4 times y1 plus c all over square root of 5 squared plus minus 4 squared. So the second point that we have was 3 minus 3, and we go x1, y1, and we sub in. So notice that our substitution is very similar, apart from obviously the point that we're subbing in. So the only real difference is that top line there. The bottom line will be the same because we're talking about the same line. So our focus is actually going to be on that top line there, and we'll discover something interesting when we work it through. So let's tidy this up. So we get 25 plus 8 minus 30. So we get the absolute value of 3 all over the square root of 25 plus 16, so square root of 41. On the right hand side here, working with the point 3 minus 3, we get 15 plus 12 minus 30. So we get minus 3 all over root 41. Now our focus is going to be on the signs inside our absolute value. So this here is a 3. Sorry, my highlighter's not working. Oh, it's just a bit slow. And this one here is a negative 3. So what we would say is, since they're different signs, they're going to lie on different sides of the line. Okay, so different signs, therefore different sides of the line. And I'll give you a little piece here that you can take down with it. So to figure out if the points lie on the same side or different sides of the line, we focus on what's inside that absolute value. So the ax1 plus by1 plus c. If you get the same signs, that means they're on the same side. If you get different signs, that means they're on different sides. So it's a nice little shortcut to have, but like I said, drawing is absolutely perfect if that's your preferred method. So example 11, angle between two lines. Find the acute angle between the lines y equals 2x plus 5 and 3x plus y equals 7. So when we have two lines, unless they cross each other at right angles, so unless they're perpendicular, we'll always have acute angles and obtuse angles. So because of the way that these are drawn with two straight lines, they are vertically opposite angles. So we're going to have just two different measures. So the two that I've shown in blue are the same size, and the two in red are also the same size. The formula which is available at the top of page 19 is the tan of theta is equal to plus or minus m1 minus m2, 1 plus m1 m2, and that is where the slopes are m1 and m2, so the slope of each line. Now, if you've already done trigonometry, if you're already familiar with that, if we're talking acute angle, we're talking about the tan of theta must be positive. If you haven't yet done trigonometry, that's okay, but we want the answer to be a positive answer. Now, sometimes students get confused and say, well, I'll take the plus. Not necessarily. If that fraction turns out to be negative, we need the minus in front of that to make the negative a positive answer. So basically, whatever answer we get with that fraction, we want to take the positive version by either putting a plus or a minus in front of it. So let's take our two lines. I have line 1 and line 2. And we have the first line, y equals mx plus c. So that's already in the correct format for us to use. So using y equals mx plus c, we can straight away see what m1 is. So m1 is going to be 2. Now the second equation is not in the correct form, so we're going to rearrange it slightly. So it becomes y equals minus 3x plus 7. So that means m2 is going to equal minus 3. And be careful to take the correct signs. So now we have tan of theta is equal to plus or minus, I don't know which one we're going to need yet, m1 minus m2, 1 plus m1 times m2. And we tidy that up. So tan of theta is equal to plus or minus 2 plus 3, which is 5, 1 minus 6, which is minus 5. Move up here. So we get tan of theta is equal to plus or minus, and this gives me minus 1. So in this case, we're actually going to take the negative, because remember, I want this to be positive because I want the acute angle. So tan of theta is equal to minus 1, which will give us the positive 1. So tan of theta is equal to 1. So to work out theta, we can do tan inverse of 1 and theta equals 45 degrees. So sticking with this formula, let's look at another example of another way to use the formula. So find the equation of two lines through the point 2, 3, which make an angle of 45 degrees with the line x minus 2y plus 1. So we're trying to find the equation of two lines. So if I want to find the equation of two lines, the two things I need are point and a slope. Now, I know my point because they're both going to have 2, 3. So all I'm looking to get is a slope. So that's what I'm looking for. It's a really good idea to break down the question to figure out, yes, I want the equation, but what exactly does that mean? What information am I actually looking for? So what we're going to do, because I want two different lines, I'm going to have two different slopes. We're going to take the slope that I don't know and we'll just call that m. The other equation, which is x minus 2y equals 1, I'm going to call that equation 1. It doesn't matter if you call it equation 1 or 2, but since we've only one equation, I think it makes more sense to call it 1. We're going to rearrange this, minus 2y equals minus x plus 1, and then divide across by minus 2. So that's half x minus 1 over 2, and that's given us the equation in the form y equals mx plus c. So that means m1 is equal to a half. We don't know m2, so we're just going to let m2 equal just m. Sometimes students leave it as m2, and that's fine, but just the subscripts can get a little bit hard to work with. You could call it anything you want, but m obviously makes the most sense. We know theta is 45, so we say the tan of 45 degrees is equal to plus or minus, and we have m1, which is a half, minus m1 plus m1 times m2, so a half times m. Now, tan of 45 is 1, so 1 is equal to plus or minus. We can tidy this up just a little bit. There's not a huge amount we can do with it right now. 1 plus m over 2. Now, we do want two values for m, so what we're going to do is we're going to split this out into two pieces. The first piece will be 1 equals, and we take the positive. So I'll put the plus here. So we're taking the plus sign, and then here we're taking the minus sign. So that leaves us just a fraction, a half minus m all over 1 plus m over 2. With the minus, it's going to be 1 equals minus, and this bracket, a half minus m, 1 plus m over 2. So we have 1 plus m over 2 is equal to a half minus m. And then we rearrange letters on the left, so m over 2, and we add m, so we get 3m over 2 is equal to a half minus 1, which is minus a half, and just finishing this, m will equal minus a third, and that's our first m. So working with the next one, so we can have 1 plus m over 2 is equal to minus a half plus m. Bring letters over to the other side, so m over 2 minus m, which is minus m over 2. And here we have minus a half minus 1 minus 3 over 2. And we figure out then m equals 3. Now, you might notice something about our two slopes. The slopes are actually opposite reciprocals, which means if we take one, the other one is flipped and the sign has been changed. So those lines are actually perpendicular, and that will always be true when we're looking at a case like this, where they're going through the same point and they're trying to make a 45-degree angle with a given line. So just one last piece that we need to do. So we're going to talk about the equation which contains the point 2, 3, and in the first case m is equal to minus a third, so y minus y1 is equal to m bracket x minus x1, 3y minus 9 equals minus x plus 2, x plus 3y equals 9 plus 2, 11. So that's one of our equations. And we'll do the same again. So 2, 3, and my slope is 3. And we get y minus y1 is equal to m bracket x minus x1. Y minus 3 is equal to 3x minus 6. 3x minus y is equal to 3. So now let's start into some exam papers just to get a sense of how these are actually asked in an exam. So hopefully at this point you're happy with all of our new formulas, and most of them are quite straightforward. There are a little few tricky bits, but in the majority of cases the way we use the formulas are quite straightforward. So this is the 2013 paper 2 question 3, and we're only going to look at this part of it. So this question part A. The equation of 6 lines are given here. Complete the table below by matching the description given to one or more of the lines. So a line with slope 2, a line with the y-intercept 0 minus 2.5, a line that makes equal intercepts on the axes. Okay, so that's kind of interesting. A line which makes an angle of 150 degrees with a positive sense of the x-axis, and 2 lines which are perpendicular to each other. Okay, so a lot of this is talking about slopes. So one thing that might be useful is to rearrange everything in the form y equals mx plus c. That way we can very quickly see the slope and also the y-intercept. So here y equals minus x plus 3. So now, really quickly, I'm able to see my slope is minus 1 and my y-intercept 3, or you can think of it as the point 0, 3. So let's look at the next one. So we have minus 4y equals minus 2x. So we have y equals, and that gives me half x minus 3 over 4. Now you can of course write that as x over 2, but because we're pulling out the slope, it is generally easier to have this as a fraction. So c in this case is minus 3 over 4. The next one is in a little bit easier form to work with. Y equals, we just need to multiply out. So we get minus 2 over 4, which is minus half x plus 7 over 4. And again we have m equals minus a quarter. No, sorry, minus a half. And c equals 7 over 4. And then here we have y equals, so that's minus 1 over root 3 x plus 10 over root 3. So that gives us the slope is equal to minus 1 over root 3. And c is 10 over root 3. And then the last one will be y equals minus root 3x plus 10. 10. So that's C, oh, that should be M. M equals minus root 3 and C equals 10. So I've actually managed to lose one of these. So this is H, this is I, this is from K, so actually I need to do L, so I'll move L over here. This is M and this is N. So L then in this case, Y equals 2x minus 5 over 2, which gave us M equals 2 and C equals minus 5 over 2. Okay, so yeah, be careful. It'd be very easy to lose one. So which line has a slope of 2? So that is line L, which has an intercept with the y-axis at minus 2.5. So the one that's 2.5 is actually this one, minus 5 over 2, so that's L as well. A line which makes equal intercepts on the axis. We'll talk about that in 1 second. A line which makes an angle of 150 degrees with a positive sense of the x-axis. We'll talk about that one in a second as well. And the easier one to go to is two lines which are perpendicular to each other. Now, be careful. M and N tends to be a very common answer here, but it's not, because perpendicular lines, their slopes are opposite reciprocals. Opposite means they have different signs. So although those slopes, the 1 over root 3 and the root 3, they're like, okay, they're reciprocals, they're not opposite reciprocals because they're both negative. So the two lines which are actually perpendicular to each other are the lines K and L, because K is minus a half, L is then opposite reciprocal, positive, and flip it. So M is 2. So let's talk about equal intercepts of the axes. So what that actually means, if we were to kind of sketch that out, it means a line that when drawn, this distance will equal this distance. So it's to try and understand how we might be able to figure that out. The second one that we kind of ignored says a line which makes an angle of 150 degrees with a positive sense of the x-axis. So there's my positive sense of the x-axis, that means the positive side. And 150 degrees is something like this. Now, it's quite hard to work with 150 degrees. So instead what we would say is, well, if that's 150 degrees, that little angle in there would have to be 30 degrees. So how would we work with angles? Well, don't forget that tan is actually the same as slope. So tan is the same as slope. So I can talk about the tan of 30 degrees. That is the same as my slope. Looking at that line, because it's going down, it will be a negative slope. So the first thing we'll do is we will go to either your log tables if you've done trigonometry and you're using page 13, or to your calculator and figure out, well, what is the tan of 30? So depending on where you're using it, you'll either have 1 over root 3 or root 3 over 3. So the first one comes from page 13. Again, if you've done trigonometry, you'll be familiar with page 13. Otherwise, you might be going to your calculator. So basically, we're looking for a line that has a slope of a negative one of these. Now, straight away, if you're using page 13, you should be able to identify it as a slope of line M. Now, root 3 over 3 is a little bit more difficult. The reason the calculator gives us a slightly different answer is because the calculator rationalizes the denominator. So if you ever are trying to compare like with like and you're not seeing it, well, try and put into your calculator the slope which we had, the one that I've circled there, the minus 1 over root 3, and that will actually simplify down for you in the calculator as root 3 over 3. So it'll give it to you in, well, it'll have rationalized the denominator. So don't worry if you haven't done trigonometry, but if you have done trigonometry, that page 13 so useful, especially because you have your log tables open when you're working in coordinate geometry. And in the case of this, like when we're dealing with slope, the chances of us having the fraction, the slope, in the form that the calculator gave us when we're talking about rational or irrational numbers, it's slim. So we've one more left to do. So a line that makes equal intercepts on the axes. So we basically want to know the x-intercept and the y-intercept. Now, we already know the y-intercept. That's the c that we've calculated. So in order to figure out where it crosses the x-axis, we let y equal 0. So let's do that for each of the lines and see what we can come up with. So I'll try to change to another color. So let y equal 0 and we get the point 3, 0. Now straight away I'm looking going, well actually my C is 3 here. So the answer to this one is H. So I didn't have to go any further. You could go further if you wanted. So like if I wanted to keep going, there would be no need. And let my y equal 0. Here I'll have 3 over 2, 0. So no, I have minus 3 over 4. So that's not the same. Over here, if we let y equal 0, we have minus 7 over 4. So that actually is 7 over 4. 0 here. Let y equal 0, 5, x is 5 over 4. I haven't really got space, but it's 5 over 4. 0, no, that doesn't match here. Y is equal to 0. So that gives me 10, 0 here. Let y equal 0, and it's 10 over root 3, 0. So the only one that the x-intercept and the y-intercept match is line H. Because they want to make equal intercepts of the x-axis, we are only looking at the actual absolute value of the number. So if that was 3, 0 and 3, 0 and 0 minus 3, that would be absolutely fine, because the length, the 3 is only representing its 3 spaces from the origin. The minus will imply a direction. So it's absolutely fine if those signs don't match. So now let's look at just part B of this. It says find the acute angle between the lines M and N. So we had already worked out on the previous page that my slope, which I'll call M1 and M2, are minus 1 over root 3 and minus root 3. And again, it wants the acute angle, so we're going to take tan as positive. So we get tan of theta is equal to plus or minus, we don't know yet, m1, so minus 1 over root 3, m2 minus root 3, 1 plus m1 minus 1 over root 3 by minus root 3. And you can go straight to your calculator and stick that whole fraction in. And when we do that, we actually get 1 over root 3. I want the acute angle, so I'm going to take the positive, well, the plus or minus that makes it positive, so that's going to be 1 over root 3. So theta is equal to tan inverse 1 over root 3. Again, if you've done trigonometry, page 13 is great for this. You don't have to mess around with your calculator and you go straight to getting your answer 30 degrees. If you want, you can put that into your calculator. Make sure you're in degree mode. So our next exam question we're going to look at is the 2015 paper 2 question 3. And it gives us the coordinates of 2 points A and B contains a T. So the line L1 is perpendicular to AB, so find the value of T. So the first thing we're going to do is we're going to find the slope of AB. So that's x1, y1, x2, y2. So formula is y2 minus y1, x2 minus x1. And we can clean that up a little bit, so that's t plus 1, and over 3. And we'll take the line L1 and we want to get the slope of this. So we're going to rearrange it into the form y equals mx plus c. 3x plus 12. Y equals 3 over 4x minus 3. So therefore my slope is equal to 3 over 4. Therefore my perpendicular slope is going to be opposite reciprocal, flip it and change the sign, minus 4 over 3. So what I know now is t plus 1 over 3 is going to equal to minus 4 over 3. I can ignore the denominators because they're the same, and I get t plus 1 equals minus 4, so t equals minus 5. So find in terms of k the distance between the point P and L1. So we have x1, y1. The line L1 is 3x minus 4y minus 12 equals 0, and that's given as ax plus by plus c equals 0. So we're using the perpendicular distance formula, which appears at the top of page 19, and that gives us absolute value of ax1 plus by1 plus c all over the square root of 3 squared, so that's a squared plus b squared. So working that through, 30 minus 4k minus 12 all over 3 squared plus 4 squared, that all gives me 5. And cleaning that up just a little bit more, we get 18 minus 4k all over 5. Okay. So now it says P, which is 10k, is on the bisector of the angles between L1 and L2. Find the possible values of k. Alright, so here are two lines. Let's call one L1 and one L2. It's only a sketch, doesn't have to be accurate. We then have a perpendicular bisector, so that cuts it in half. And we have this point P that is on the perpendicular bisector. So what we actually know about this is if I draw a line perpendicular here and here, those perpendicular distances are actually the same. So the distance between P and line 1, which we worked out on the last part, that was 18 minus 4k all over 5. So that's the distance between P and L1. That should be equal to the distance between P and L2. So working that through, L2, so let's actually label this very quickly. So that should be ax plus by plus c equals 0. This is still x1, y1. So we have a x1 plus b, oh sorry, that should be k, y1 is k, plus c all over square root of 5 squared plus 12 squared. So let's clean that up. So I get 18 minus 4k over 5 is equal to 50 plus 12k minus 20, and square root of 5 squared plus 12 squared is 13. Cleaning that up, 18 minus 4k over 5 is equal to, in this case, 30 plus 12k over 13. Now, in both of those top lines we can pull out something. So in the top line here I can pull out a 2. So 2 times the absolute value of 9 minus 2k. And that's still over 5. Here 2 as well. Pull out a 2. 15 plus 6k, and that's all over 13, and those 2's actually cancel. So the 2's, that just simplifies it a little bit. So what we have now is the absolute value of 9 minus 2k, and actually I'm going to multiply this by 13. So 13 times that is equal to 5 times 15 plus 6k. Now, absolute value sign. So one way that we can get rid of that is by squaring both sides. Now, if you do square both sides, you're going to get something that is quite complicated and it's going to take a while to work with, and that's absolutely fine. It is completely doable. However, to speed this up, we're going to use the idea that what's in those absolute value signs could be positive or could be negative. So what we'll do is we'll take, it doesn't matter which, and we'll say that maybe that's positive, maybe that's negative. So I'm going to take it as the second bracket. So the first option, so this is option 1, is the 13 times 9 minus 2k is equal to plus 5 times 15 plus 6k. And we can work that through. And the second one, I'll work that through in a second. The second thing I can say is 13 times 9 minus 2k. That could be equal to the negative version of 5 times 15 plus 6k. So a little bit easier than squaring, especially given that we have 2 brackets here squaring out. Now, like I said, there's no issue squaring it and multiplying out and then doing minus b formula because the numbers will be quite big. But this is just a shortcut. So let's work it through. So that's 117 minus 26k equals 575 plus 30k minus 56k equals 75 minus 117, which gives us minus 42. And k then is equal to minus 42 divided by 56. And that simplifies down 3 over 4. If you want it in decimal, 0.75. So let's work through here. 117 minus 26k equals minus 75 minus 30k. Bringing 30k across, we get 4k here. So here we get minus 75 minus 117. That's 192 negative. Divide that by 4. And k is equal to minus 48. So there are 2 values of k. Just get rid of this little line. So there are 2 values of k, but like I said, if you want to square it and work minus b, that's absolutely perfect, but that's just a little bit quicker. So then it says if k is greater than 0, so that means only one of our values is valid. So the value that is valid is 3 over 4. Find the distance from P to L1. So that's basically us going back to 18 minus 4k all over 5 and subbing in. So the absolute value of 18 minus 4 times 3 over 4 all over 5 minus 3. So absolute value of 15 over 5. Absolute value of 15 is just 15 over 5, and that gives us the distance of 3. Okay, so let's take a look at our next exam question. So this is example 15, which is from the 2014 paper 2, question 5. It says the line or S, which is shown on this diagram here on the right, cuts the x-axis of the point or and the y-axis of the point S, which is 0, 10, as shown. The area of the triangle, or OS, where O is the origin, is 125 over 3. Find the coordinates of OR. So the OR here has an x coordinate, but no y coordinate because it's on the x-axis. So we can label this x1, y1, x2, y2. Area of a triangle formula is a half the absolute value of x1, y2 minus x2, y1. So that formula is given towards the end of page 18. Your log table, so this is a half, x1 is x times 10 minus 0 times 0, and that is equal to 125 over 3. And now we'll work through it. So we get the absolute value of 10x is equal to 250 over 3. Now, I know my x is actually going to be negative, so what we can do is say 10x is actually going to be equal to negative 250 over 3, because x, look where it is on the x-axis. So if this is my 0, 0 point to the left of it, x will have to be negative. So I've made it positive. So then x is equal to 25 over 3, and that's a negative. So the coordinates of O, or, is 25 over 3, 0. So show that E is on the line or S. So there is actually two different ways to do this. I think the go-to for many students would be to work out the equation of or S. So we'll work this way. I'll show you both ways. Equation of or S. So the point, probably easiest one to use is S, and then the slope. We can do rise over run, and it's positive. So it's going to be 10 divided by 25 over 3. So that's my rise. That's my run. So that's 30 over 25. So that gives me 6 over 5. So that's my slope, positive. You can also work that out with your y2 minus y1 over x2 minus x1. So I now am going to work with my equation. There's x1, y1, and there's my m. Y minus y1 is equal to m x minus x1. So we get 5y minus 50 is equal to 6x. And then I want to see, does the point E sit on this? So minus 5, 4. So we will sub it in. So we get 5 times 4 minus 50. Does that equal 6 times x? So 20 minus 50 is minus 30. And 6 times minus 5 minus 30. So perfect. Therefore, E is on the line or S. Now, I did promise the second way where we could do this. So the second way we could do this is actually just by using our slopes. So this is actually a way to talk about points being collinear. So collinear means sitting on the same line. So basically, if we can find the slope of RE, and we found that that is equal to the slope of ES, then they will be collinear, because if those slopes are the same, it must be the same line. So if we want to get the slope of RE, so this case better to y2 minus y1 and so on. So y2 minus y1 over x2 minus x1, so that's 25 over 3. And you want to see, is that equal to the slope of ES? So y2 minus y1 all over x2 minus x1. So that's plus 5. So work that through. So that works out as 6 over 5. Here we get 4 over, so 3 minus 15. And minus 15 plus 25. So this actually works out as 10 over 3. And tidying that up gives us 12 over 10, which is equal to 6 over 5, which is equal to 6 over 5. So therefore they're collinear, so therefore E is on the line or S. It is a little bit quicker, there's a little bit less work to it, but it's a little bit harder to remember, but it is a really useful little kind of little piece that we can use if we ever want to check that a point is on the line and we don't actually know the equation of that line. So a second line, y equals mx plus c, where m and c are positive constants, passes through E and again makes a triangle of area 125 over 3 with the x-axis. Find the value of m and the value of c. So there's a few different ways it can happen, but we're just going to sketch one out. So we're going to say it kind of comes through something like that. Now we have 2 points here that we don't know. But because we're dealing with y equals mx plus c, we can get the y and the x-intercept. So the first one is that y equals 0. So 0 equals mx plus c. So c is equal to, x is equal to minus c over m. So my point here is minus c over m 0. And that's that point here, minus c over m 0. I'm putting everything in terms of c and m because that's the two constants that I want to work out. The second one is x equals 0. So y equals m times 0 plus c. So y equals c. So that's 0, c. And that's that point there. So you might have just been able to write that down without working it through. Either way, it's absolutely fine. So we know the area of the triangle. So let's start with our 2. So we have minus c over m 0. And we have 0c. We get x1, y1, x2, y2. We have a half x1, y2 minus x2, y1. And when we do that, that should be equal to 125 over 3. So we get a half minus c over m times c minus 0 times 0. 25 over 3. So we get a half minus c squared over m equals 125 over 3. So c squared over m is equal to 250 over 3. Now, some things to note at this point. First, we'll deal with the absolute value signs. C is definitely positive, and M is also positive. They told us these are positive up here in the question, therefore I can drop the absolute value signs. So actually c squared over m is 250 over 3. Now, problem, I actually have 2 unknowns, so I'll need a second equation. So students are usually quite good at getting to this point in some way, shape or form and struggle with the second one. The second piece of information, and it's kind of easy to skip over, and it passes through the point E. So the line passes through E. So the line E, which we had in the last part, that was minus 5, 4. That sits on the line y equals mx plus c. So actually, we can sub that in. 4 equals m times x plus c. So 4 equals minus 5m plus c. So that actually becomes equation 2, and now we have simultaneous equations. Doesn't really matter which way you work. We might go back over here to equation 1. So c squared equals, well, we'll multiply this by 3, and that's 250m, and we can do a little bit of substitution. It depends if you like squaring or not. I would prefer not to square if I could. So 5m is c minus 4. M is equal to c minus 4 over 5. So I'm going to sub that in. Okay, so I'm going to sub 2 into 1. So 3c squared is equal to 250 c minus 4 over 5. I got a little bit of cleanup here, 50, so I got 3c squared is equal to 50c minus 200, 3c squared minus 50c plus 200 equals 0. And you can work through minus b if you prefer here. We just need to solve it. So I'm going to use guide number, and when I do guide number, I'll get down to 3c minus 20, c minus 10 equals 0. So c equals 20 over 3, or c equals 10. Let's just block this off for a second. You got 2 answers, but there was never a mention of 2 particular answers. So you need to be kind of on the ball here and realize that this answer is incorrect. And the reason being that c equals 10 actually is the point S, which we've already worked with. So we must be working with the c is equal to 20 over 3. So we want to go sub that back in. So so going back to equation 2 here. So m is equal to c, which is 20 over 3, minus 4, all over 5, and that equals 8 over 15. Now in this question, there is no requirement to go back and actually get the equation of the line. We can leave it just with our c and our m, because that's what they were asking for. Find the values of m and c. So now let's look at example 16, which is the 2014 sample paper 2, question 5. So part A is show that for all k elements of the real numbers, the point P, which is given here, lies on the line. So anytime we talk about a point being on a line, on the circle, even on a function, we can substitute in to the given equation or the given function, and it should work. And what I mean by work is it is an equation, so the equation should balance. So what we're going to do is we're going to sub in 3 times. Instead of x, I'm going to put in the 4k minus 2. And then minus 4. Instead of y, we're putting in 3k plus 1. Then plus 10 equals 0. So multiplying that out, 12k minus 6 minus 12k minus 4 plus 10 equals 0. The 12k minus 12k goes to 0k. Then minus 6 minus 4, we've minus 10 plus 10, and that is 0 equals 0. Therefore, P lies on line L1. So all we're being asked to in this case is just substitute in. So then it says the line L2 passes through P and is perpendicular to L1. Find the equation of L2 in terms of K. So first thing we need to do is figure out, if I want to get the equation of a line, what 2 things do we need? So we need a slope and we need a point. Now, we do know the point because it goes through P. So we have P, which is 4k minus 2, 3k plus 1. And that will be our x1, y1. We need a slope, which is m, but we don't know that yet. So in order to get that, they've told us that this line L2 is perpendicular to L1. So what we can do is figure out the slope of L1. So taking the equation of L1, which is 3x minus 4y plus 10 equals 0, rearranging it in the form y equals mx plus c minus 3x minus 10. So y is equal to 3 over 4x plus 10 over 4, 5 over 2. So that gives us here our slope. So m1, so the slope of line 1 is 3 over 4. Therefore, the perpendicular slope is going to be minus 4 over 3. So it's opposite reciprocals, which mean we change the sign and we flip the fraction. So that is the slope of line 2. So we bring that over here and we work with our equation. So the equation of the line is given by y minus y1 is equal to m bracket x minus x1. And we sub in what we know. They want it in terms of k, so it's absolutely fine to have k in our answer. So we have y minus 3k plus 1 is equal to minus 4 over 3 x minus 4k minus 2. So we want to clean this up a little bit. First thing we're going to do, multiply both sides by 3. So we get 3y minus 9k minus 3 is equal to minus 4x minus minus plus 16k. Minus by minus is a plus, by a minus is a minus, minus 8. Want to get the k's and the numbers together. So we're going to have 4x plus 3y equals, we have a 16k plus 9k, so that's 25k, and minus 8 plus 3 minus 5, and that's the equation of L2. Now, they didn't give us a particular form to have it, so if you had that 25k minus 5, the other side and your signs were different, that's absolutely perfect. If you have x's on one side and y's on the other, again, once your signs are all lined up, absolutely no problem at all. So part C says find the value of k for which L2 passes through the point Q. So just to remind you, we just worked out L2, 4x plus 3y is equal to 25k minus 5. If a point is on the line, we know that when I sub it in, it should work, so the equation should balance. We can use that to solve for k in this case. So we have 4 times 3 plus 3 times 11 equals 25k minus 5. So we have 12 plus 33 plus 5 equals 25k. I like to have my letters on the left, so I'm going to just flip it around. So we have 45, we have 50, and then k equals 2. So not only can we use this method of substitution to check if a point is on the line or on a circle or on a function, we can also say, well, if we know that the point is on the line or on the circle or on the function, we can use the substitution method to either create an equation to solve or to create an equation to just have the equation there. So part D says, hence or otherwise, find the coordinates of the foot of the perpendicular from Q to L1. I think the wording in this is a little bit tough for students, so let's break it down. So hence, so using what we've just done, or otherwise, so if you don't use this particular method and you do it another way, there's no issue. Find the coordinates of the foot of the perpendicular from Q to L1. Now, I think the first thing that caused a little bit of confusion here is the diagram. So I've pulled in the diagram from the start. There's an arrow here which basically says because P is in terms of K, it can move up and down this line. So it is basically any point on that line. So the P which we're talking about is this value here. So we've basically worked out a value for K. And that value for k gives us a point that is right here. And when we talk about the perpendicular, we're talking about a line that goes through this perpendicularly. And we had the point P, which was 4k minus 2 and 3k plus 1. And we've basically found, well, the line that goes through Q, the point P will have a k equals to 2. So we can sub in 4 times 2 minus 2, 3 times 2 plus 1. And we get 6, 7. And that is the coordinate of P, which is this point here. And that is the foot of the perpendicular from Q to L1. So the foot of the perpendicular, basically the point where that line from Q to L1 meets. So the line that goes from Q to L1, where that meets the line L1. So all they're asking in that part is to find P. So don't let the wording confuse matters.